What is up, most distinguished patrons of this channel? Today we are going to continue how to TIG weld series, and we're going to be dealing with lap welds and everything you need to know to master them. So let's get into it. This is video number 8, and it goes without saying that this whole series that I'm making for you guys out there is really designed to go through video by video. And if you're starting off on this, that's fine. You can watch it, learn a bunch, but I'm not going to be covering a lot of terms and a lot of things that the previous videos covered. So you might be sitting there wondering yourself, what the hell is this guy talking about on certain things? Well, guess what? It was probably explained in earlier videos. And I do that so that I don't have to waste a whole lot of time making every video essentially a start to finish lesson, especially because I already talk too much and there's already too much information in these videos as they are. So anyways, we're going to be dealing with lap welds, and lap welds are simply two plates that overlap, such as this. In my welding career and just in general fabrication, it's far more common to do a lap weld than what I did in a previous video, which was more or less butt welds. Butt welds on plate like this is just fairly uncommon. Lap welds are far more common. Even more common would be fillet welds, but that's a whole nother video. So we're going to be talking about lap welds. Now for what we're doing today, we're going to be focusing on using 1/8 inch, so a roughly 3.2 millimeter, as well as 1/4 inch plate, which is for you guys across the pond around 6.4, 6.5 millimeters, so pretty thick plate. Doing thin material is actually fairly easy to weld with this. I will have a whole video on TIG welding thin material where I'll cover all of that. But for right now, we're going to focus on stuff that you're probably not going to end up burning a hole through easily. And that's why we're doing it, is just to make life a little bit easier while you learn what the hell it is you should be doing with this. So anyways, let's do a little bit of book learning first so we get some things, a little bit of the muddy water cleared up, and then we will go and actually do some welding. So in front of us is a not true to life scale drawing of thin, medium, and thicker steel. So thin would be like your sheet metal, so something under 3.2 millimeter by quite a bit, so 1/16 and thinner, or I don't know, 2 millimeter and thinner. We have a depiction of 1/8 and a depiction of 1/4, obviously sizes as listed. One of the confusing things about lap welds that people screw up, myself included, when I was learning to TIG weld, is I didn't understand where my tungsten and arc placement should be. On super thin material, it's very common to have your tungsten more or less come in at this angle, and you're nipping the top edge and melting it down into the base material, especially if you're just doing a fusion weld and you're not using filler. And because the material is so thin, you can get away with this, and that works just fine. What you're going to find is on super thin, if your tungsten angle's out here and you're trying to melt this down, you'll probably poke a hole right through this, and you don't want that. So on super thin, you want to aim for this top edge of the plate and melt it down. When you deal with 1/8 inch material, what you're going to find is that if you attempt to come in with an angle directly on that edge of the plate and try and melt it down with filler or without, the probability of you having poor fusion, where this is going to more or less melt down a little bit and your weld isn't going to be very thick. And what I mean by that is, I'll draw it now. Your top edge of this plate will melt down like this, and yeah, you melted this, but your fusion area is going to be a very small area down here because all you're really doing is melting this edge off. You don't want that, which is why in the case of 1/8 inch and thicker material, you're actually far better off moving your tungsten angle in and aiming at this joint right here at the inside corner and focusing your heat on that and trying to melt this section right here. And because you're dealing with thicker metal, it's less likely to blow a hole than with thin material. And somewhere between 1/8 inch and thin material is kind of like a crossover point where you no longer want to focus at that edge and you want to focus in here. And the easiest way to find out if what you're doing is working is make a decent looking weld on a lap weld and then cut it and etch it. And if you start seeing some wild stuff like a very small fusion area right here, then you probably need to bring your tungsten in and hit it at this angle down here. Now it becomes more blatantly obvious when you weld thicker material like 1/4 inch and above. With that material, you simply can't focus your heat and your arc cone and your tungsten up here on this edge. Literally, all you will do is round over that edge and you will have zero fusion here. So that becomes an impossibility on thicker material, and that is why you need to focus your tungsten and your arc cone right down in here so that you can fuse this whole area back in here. Now, when it comes to lap welds, the thicker it is, the more it functions like a fillet weld. So a fillet weld would more or less be like a T-joint, where you have a plate like this. Kind of a poor drawing there. But the thicker it is, you basically weld it just like a fillet weld. And on 1/4 inch plate, it welds identical to a fillet weld. There's really no difference. So that's why lap welds, especially on thicker plate, are a more economical, faster way to learn to weld fillet welds than it is to do actual fillet welds, because you can get by with far less material, more practice, etc. You get the picture. So really the key takeaway in what I'm showing you here is that your tungsten should really be focused at that inside corner part of the joint on anything 1/8 inch and above. And around 1/8 inch and thinner, you need to be up on the top edge of it in order to weld it, or you risk basically melting through the bottom plate. The other thing to keep in mind is you should be doing this after you've done a bunch of beads on plate and you've mastered simple, short, perfect looking, or at least reasonably good welds, just flat beads on plate, right? So one of the things you got to remember with this whole deal here is when you're welding two plates together instead of just a bead on plate like you should have practiced a bunch by now, two plates together and adding filler takes far more heat input than just a bead on plate. A simple bead on plate like this, just running a bead, you might be able to do it at 60, 70, 80 amps, perfect, no issue, right? Well, when you go up to 1/8 inch material and two of them, 60 amps is barely going to make a puddle between the two. And then on top of that, when you add filler, it's just going to quench the puddle and you're going to stick your rod. So you can't be afraid of amperage. On an 1/8 inch material, it's not out of the question to be at 120 amps or above, and your travel speed will also likely have to be slower than just running a bead on plate, because you have to give it time to melt the metal for it to fuse together and to progress forward. That takes more time because you're melting more metal. The alternative would be to run way more amperage and run fast, but there's limitations to that too. It's very easy to lose penetration. And in the case of this, you should be focusing on more or less a slow, steady speed and focus on letting it sink in a little bit rather than seeing how fast you can get the job done. Depicted here is what we'll call 1/4 inch plates. Obviously, in this case, they're at least an inch, inch and a quarter, but obviously it's not to scale. One of the things you're going to notice on thicker plates, like even these coupons show evidence of it, is that the edges tend to be rounded. And that's very common with any kind of steel you might buy that's hot rolled. The edges tend to be rounded. That can pose a problem because if you don't use enough amperage and you more or less just lay a bunch of metal on it, what can happen is your weld can more or less bridge over this and leave this completely untouched. So on thicker plate, it is imperative that you use enough amperage, like 1/4 inch, 6.4 mil plate you need with TIG anyways, need to be up 120, 130, 140 amps in that ballpark for a root pass on a joint like this in order to get this all fused together. The other thing that's very important is you guys got to understand that TIG welding is not a high metal deposition process. You do not need to be attempting to do a one-pass weld on 1/4 inch thick steel and call it good, especially if you're a beginner. Don't get me wrong, 250, 300 amps in the right size filler rod, and all day you could do a single pass weld on this, but most of you at home don't have that kind of welder, not to mention you don't have the skill likely to do that. So what you need to focus on 1/4 inch plate with TIG is at a minimum a 3-pass weld. So you would have your initial root pass in here like this, you would have a second pass up here, and then you would have a third pass up here, which I know probably seems ludicrous simply because on 1/4 inch plate you can one pass that with stick or MIG all day long without any real huge issue. But again, TIG is a low deposition process, and you do not want to be trying to do big, huge welds with it. So a 3-pass weld for you as a beginner would be what I would aim for. Now, as you become more experienced, you would do such a weld as this in 2 passes. You would do your initial root, and you'd more or less weave a cap and fill pass in one shot. So higher skill, you can do that. At your entry level, moderate skill, don't be trying that. You're probably going to cause more weld defects than what you would really want to see. So that's what you should be aiming for. Realistically, 3-pass, stick with that to fully weld it. And the goal is to have the weld up here on the corner all the way down to here. And you can see with this is that if you had really poor fusion here and it bridged over here and then you under-welded it so you stopped like right here, you might only have a connection point that's very small between the two pieces, and you don't want that for most things. For non-critical stuff where a simple little weld will work and hold it together, sure, you can do that, but anything requiring strength, you need to fully weld it out with some form of root fusion penetration there. The last thing I'm going to talk about is doing fusion welds for an initial root pass on something like this. My recommendation is not to do it, and the reason is simple, especially on thicker plates. So anything thinner than 3.2, you could probably do a fusion weld and get away with it, but on thicker stuff, trying to do a fusion weld for the root is going to end up doing this. So it's going to nip that edge off. You might get some tie-in back here, but it's going to basically leave undercut. Now, could you do another weld over it to fill it out? Absolutely, you could, and that could be strong. But in a general sense, you are better off adding filler. The filler material has deoxidizers. It has things that will help that molten metal both flow and not really reject impurities, because it does and it doesn't. The fillers have alloys that do help with that, but by just fusion welding everything, the probability of having weld defects in here, such as porosity or other poor grain structure issues, is much higher in my opinion. And I think Lincoln Electric, Miller, and everybody else would agree. So this is not an application you would want to do just a fusion weld and then start adding filler. You need to get good at adding filler anyways. So keep the fusion welding for the thin material and outside corner joints and stuff. Anything thicker than 1/8 inch and thicker, don't be doing this. Use filler, add filler. If for whatever reason you don't want your weld to stick out further than the point you see here, but you want a lot of strength, in that case, if you were to bevel this back and then fuse it all the way from here with multiple passes and your weld doesn't stick out far, that would also be acceptable because you have a very strong joint here. But if you're just going to fusion weld it and leave it and you want strength, yeah, you're barking up the wrong tree, buddy. All right, let's get set up and do some welding. So to start things off, we're going to use 1/8 inch material. I'm going full pedal. I'm not using the foot pedal for amperage control, nor should you when you're learning at first. I started the arc, allowed the puddle to cross over between the pieces, and in this case I'm aiming at that top edge more so than a flatter angle into the joint. And this is a fusion weld, so I'm just melting off that top edge primarily into the bottom plate and creating a weld that way. We're going to look at a different angle of approach with a little bit better detail, a little bit better clarity shortly. But everything is going well here, very consistent arc gap, consistent travel speed. This is what you want. Realistically, I could have used more amperage, but it worked. So now let's look at what that looks like when we're done. So not the best looking fusion weld, but it will definitely hold. Again, 1/8 inch isn't something you really want to be doing fusion welds on. Generally, it should be reserved for a lot thinner material, but it did weld it and it'll work. Now let's look at a little bit more of a flat angle where we're aiming more towards the root of the joint per se. So as you can see, I have a much flatter tungsten angle. I'm aiming more or less at the root of it rather than that top edge. I'm producing a much smaller fusion weld. Keep in mind, I'm still melting off that plate edge down in order to create filler, but the angle is a lot different, and this is more or less what you would want to do if you're adding filler rather than just trying to melt that whole top edge down. Again, this is just a fusion weld, but everything's looking pretty good, a little bit different of an angle. Now let's look at both of those side by side. So the top video, we're aiming more or less for the root of it, and the bottom one, we're aiming more or less for the top edge. So again, top edge for thinner material, and the root of it for anything 1/8 inch and thicker. This is still the 1/8 inch material as we were previously welding. When it comes to the tungsten angle, I'm using a fair amount of a push angle, and that's so I could see what I was doing, because I was doing all this welding watching it through the camera itself. So it was a little bit easier to film and for me to see, but ideally you'd want more of a straight in angle. All right, let's move on. So to put these differences in real world perspective, look at this picture. The weld on the right was done where I was focusing more heat on the top edge of this 1/8 inch plate, and it more or less melted it down into the bottom plate. And the weld on the left is what happened when I focused that arc on the joint. Both of these have filler material added to them. Now the weld on the left is a little bit concave, and that's very typical of TIG welding in general. You have to push enough metal to bring that out to a 45-degree angle. The concave bead isn't really a huge issue, I guess. It's a little bit thin in the throat depth, but it's not bad, but acceptable. But the penetration and overall look of that cut and etch is way better on the left, focusing that heat on the root versus the one on the right. Had I moved faster or used less amperage for that weld on the right, there'd probably be no fusion whatsoever, and more or less the weld's actual throat depth, aka what's joining the two pieces of metal together, would have been even thinner than where we're at here, therefore it'd be very weak. And this is exactly what you would expect to see depending on where you're focusing your arc on. And that's why it's so important that once you get good enough at lap welds to where they look decent, I guess, you want to cut it and etch it and see what's going on inside to see if the internal looks as good as the external. Because TIG welds can be just like MIG welds, where visually they look okay, but internally they're not. All right, let's move on. So now we're going to watch what happens when you don't use enough amperage. In this video clip, basically I'm running 60 amps, 55 amps, and it's melting the top edge of that 1/8 inch material and a little bit of a puddle down below, but it's taking an astronomical amount of time for anything to happen. Eventually I'm able to join that material together, but when I try and take off moving forward, it's more or less making a horseshoe shape, and it's trying to stop fusing the two, and you don't want that. If you see that, you're probably either running too long of an arc gap or not enough amperage. So again, here's a video clip where we're running a little bit too long of an arc gap and not enough amperage. You can see how it kind of wants to melt two puddles and no joining of the two. Once I tighten the arc up, they'll kind of pop together. So again, if you're running too long of an arc gap or not enough amperage, you can expect to see that. So now let's add filler. We're going to use 1/16 filler and add it on the same 1/8 inch plates. Now I started the arc, let the puddle cross over between the pieces, and now I'm just dabbing it into the puddle, running 120 amps or so here. Now because I'm filming this and watching what I'm doing through the camera, you can see it's a little bit inconsistent, and that has to do a lot with my ability to see what's going on. But this is a pretty rough idea of what you should be seeing when you're trying to practice this. Now let's look at another joint where I changed the tungsten angle a little bit. So now on this one, I'm using a little bit flatter of an angle. I'm trying to hit more of the root of the joint, and I'm pushing enough filler to bring the weld up to that top edge. By doing so, it creates more or less a 45-degree angle from that top edge to the bottom plate. That would be more ideal, and it doesn't nip off as much of that top plate as well. But this is going pretty good as well, and this would be my preferred method on how to weld something like this, rather than trying to melt more of the top edge with a more straight up and down tungsten angle. I'm also keeping that filler rod in there tight. That's what you want to do. All right, let's watch that one again. I won't comment on this, just watch this. This is what you should be seeing. So now let's look at a lap weld on 1/4" material. I slowed it down about 50%. I start the arc, wait for the puddle to join the two pieces. In this case, I'm running around 120 amps, which is honestly too cold for a 1/4" material. I generally would prefer to be at 140 to 160 amps for a single pass on this, for at least a root pass, just to make sure I'm melting everything together. You guys got to remember, the higher the amperage, the wider the arc cone, therefore the more filler you have to push in, but the bigger the weld. At 120 amps with a tight arc, that is so neck down in there that I'm not really depositing much metal at all. I am retracting the filler rod out so I can see the root fuse, putting it back in and pushing a little bit of pressure in it so that it actually deposits some metal. The other thing worth noting is that the molten puddle is the shape of a triangle, and it comes to a point with the point right at the root of the joint. If you don't run enough amperage, you're not going to get that point there, and you're more or less going to lose all your root fusion. So that's a good sign that we're seeing that. Well, let's look at that in real time now. Let's watch one more just to get an idea of what it should look like on 1/4". So a couple other tips for you guys. I didn't mention it earlier, and it's completely my oversight. When you're doing lap welds, you should overlap the plates with them overhanging on the edge. And the reason for that is you get extra practice, that little extra 3/4 of an inch or an inch or whatever you have there. And on this side is extra stuff that will help you become better. The other thing you can do is to take, luckily that wasn't hot, more plates and then stack them, and that way you get more practice for the material that you actually have. So that is going to be very handy for you guys as well to get more for your money. But if you set up a good 8, 10, 15, hell, even 20 of these plates and just keep focusing on just keeping that arc tight in that corner if it's thicker than, say, 1/8 inch or thicker, and if it's thinner on that top edge, and just focus on doing that. Start with fusion welds, and once you can reliably get a straight fusion line like what you see here, then start adding filler, and everything after practice of doing about, I don't know, 100, 150 of these, you'll be able to be 100% on point. The quality of what you're going to be doing will be there. And it really comes down to doing enough practice, and as always, keeping that tight arc gap. All right, well, I think we can go to conclusion now. So, in conclusion, what did we learn today? Well, we learned how to master simple lap welds with 1/8 inch material and 1/4 inch. Now, off camera, and this sucker's probably too hot for me to handle, I did what was a 5-pass weld, so a root pass, 2 fill passes, and then a cap pass, and I'll put a picture of it up right now just to demonstrate one way that you could TIG weld a 1/4 inch steel lap weld. Now, I'll be honest with you guys, when I'm welding 1/4 inch, universally, I'm not TIG welding it for a lap weld. I'm probably spray arc welding it or stick welding it. And the reason's simple. TIG is so slow. And I welded that at about 150 amps. If I had cranked it up to 200 and used even bigger filler rod, I only had 1/16 handy. If I had used 332 at 180 to 200 amps, I could have done that in 3 passes. No problem, even 2 passes, just a root fill and then a cap. So there's all sorts of ways you can do thick metal, but let's face it, the reason you're using TIG is to make high quality welds and likely on thinner material. And in that case, oftentimes all you need is 1 pass to make it good. And the key takeaways, as always with TIG welding, is you've got to maintain a consistent arc gap, you've got to be smooth, and you have to add filler material consistently. It's just 100% it comes down to consistency, and the more consistent you are and the smoother you are, the better your welds come out. And that's something that really comes down to practice. When you do it so much that it's hard to do it wrong, that's how you get good at TIG welding, especially on lap welds. So with that said, hope you enjoyed the video. If you got any comments, questions, thoughts, concerns, you know where to leave them. Until next time.